Let's look at OpenStax College Physics, Chapter 19, Problem 23. An electron is to be accelerated in a uniform electric field having a strength of 2 times 10 to the 6th volts per meter. A. What energy in kilo-electron volts is given to the electron if it is accelerated through 0.4 meters? And B. Over what distance would it have to be accelerated to increase its energy by 50 giga-electron volts? So let's write down the things that we know. We're dealing with an electron, so the charge of the electron is negative E, or negative 1.6 times 10 to the negative 19 coulombs, and it is accelerated in a uniform electric field that has a value of 2 times 10 to the 6th volts per meter. And we know that in part A, it is accelerated through a distance d of 0.400 meters, and we're looking for the change in kinetic energy. And in part B, we know the change in kinetic energy is 50 giga-electron volts, and we're looking for the distance. So as a diagram, if we have an electric field in this direction and we place a negative charge, an electron, in the electric field, then the electron will be experiencing a force in this direction and it will be accelerated due to this force. So we know that there is an electric potential energy that the electron is experiencing here, and that will be converted into kinetic energy. So we'll say that electric potential energy is converted into kinetic energy. So the electric potential energy is the charge times the change in potential, and that will give us the change in kinetic energy. But we know that there is a relationship between delta V and the electric field, and that would be E times D, and that's equal to the change in kinetic energy. So now we know everything we need for part A. So for part A, we know that delta KE then is QE times D, and Q is the charge, is the absolute value of the charge, 1.6 times 10 to the negative 19th coulombs. Electric field is 2 times 10 to the 6th volts per meter, and the distance is 0.400 meters, and this would give us the answer in joules, but we want the answers in electron volts, so we know that 1.6 times 10 to the negative 19 joules correspond to 1 electron volt. So then if I divide this by 1.6 times 10 to the negative 19, then I end up with my answer in electron volts. So the answer then becomes 0.8 mega electron volts. So 0.8 times 10 to the 6th electron volts. Then in part B, we're still starting out with the basic theory here where the electric potential energy is converted to kinetic energy. But now we know the delta KE and we're looking for D. So the distance then is delta kinetic energy divided by Q times E, and that is 50 giga-electron volts. Giga is times 10 to the 9th, and we have to convert from giga-electron volts into joules, so that's 1.6 times 10 to the negative 19th, divided by 1.6 times 10 to the negative 19th, times the electric field, which is 2 times 10 to the 6th, and we're left with 25 kilometers.